Good afternoon to all of you. I warmly welcome all the participants and resource persons for the second technical session on land management. Dr. Milinda Piasena, Senior Lecturer, Department of Surveying and Geodesy, will be handling the event. Before handing over the session, let me tribute him with a small introduction. Dr. Milinda obtained his PhD in Europe Urban Studies in Institute of Europe Urban Studies, Bohas from the University of Weimar, Germany in 2015. He completed his MSc in Land Management and Land Tenure from the Technical University of Munich, Germany in 2007. He also obtained his Bachelor of Surveying Sciences from the Saarbrücken University in 2002. He is an expert in land management and land tenure. His field of interest is land tenure, security and slum upgrading, and presently he holds the responsibility as the coordinator, quality and cell for the Faculty of Geomatics. Now I would like to cordially invite Dr. Milinda Piasena to conduct the technical session on land management.
Thank you very much. Am I audible? Yeah.
Yes, Dr. Milinda, yes.
Okay, right. Thank you very much. So, good morning and good afternoon, depending on which part of the world that you are in. So, I would like to welcome all of you to this session.
Recording in progress.
First of all, I would like to welcome Dr. Rees, our plenary speaker for these sessions. Good morning, Professor. Right.
Good morning. Yeah.
How are you doing there?
Yes, everything okay. It's pretty cold.
Okay.
Yeah, already.
Right. So then I would like to welcome our plenary chairperson of this session, Professor Jagat Munasinghe, and also I would like to welcome Mr. Vipula Abhiratna, Dean, Faculty of Geomatics, and also the heads of the departments, as well as the judge panel, Dr. Dusra, Dr. Nishamani, as well as Ms. Samanthi Munasinghe, as well as I would like to welcome all the research presenters here and academic staff and ladies and gentlemen all. So my task first would be to introduce our plenary speaker, Professor Walter D. Vries. So Professor Walter D. Vries acquired a geodetic engineering degree from the Technical University of Delft in 1988, and he completed his PhD at Rotterdam. He has worked in international projects in Asia, Africa, and South America with the UNITAR in Geneva till 1994, yes. And with the International Institute for Geoinformation Science and Earth Observation, ITC, at the University of Twente from 1994 to 2015. He was then appointed to chair positions at TUM in 2015. He is the director of the TUM Masters and PhD program in Land Management and Land Tenure. And he serves as the Dean of Studies of the programs Geodesy and Geoinformatics, and as an academic coordinator for TUM Africa. He is a member of the German Geodetic Commission and member of the Bayern Academy of Rural Spaces. In his research interest of the Professor Vries include smart and responsible land management, urban and rural development, public restriction and cadastre, capacity development for land policies. He supervised doctoral candidates dealing with spatial development strategies, land tenure arrangement, spatial justice, nomadic pastoralized land tenure, and land conservation, among others. He's working on a theory of and framework for human geodesy. So, Professor Breeze, the floor is yours. I think you are going live today. So, please, you are welcome to initiate with your presentation. Thank you very much.
Yeah, thank you very much. A very extensive introduction. Yeah, that's quite honoring, I must say. We know each other already for quite some time, and I also we are working together on a book on geospatial science and land management. So yeah, I'm very glad to be here, be it online. Next time I'll try to be there in presence. What I want to talk about today is something which combines both land management and geospatial science. And that is a project that we're working on, or a research that we're working on for and in Indonesia. It actually deals with the development of the new capital of Indonesia. And I'll try to share my slides. I hope that you can see my slides also in slide mode.
Yeah, we can see it.
Yeah. Okay. So I'll talk about the new capital of Indonesia. You probably know that the current capital is Jakarta, but the government made a plan to relocate its capital to an island, Borneo Island, or actually in Indonesia it's called Kalimantan, and to locate it in this new area. And they've already started with that. That is, they have, and that is a very nice geodetic term, they have created a so-called titik nol, a 0 point, where the capital, from which the capital should be developed. There's several plans for this capital, this new capital. And that is also a little bit the uncertainty, what is happening with that capital. They know the 0 point of the capital, but they don't know yet how it should or would develop. There are some plans for a small development, or a development of a small capital, but there's also plans for the development of a larger capital. And at the same time, there's also just simply dynamics of how cities develop once you start a city or once you build a city. So the general design is some of these pictures that you see here. It is located in an area that is currently mostly tropical forest area, and also an area of many rivers and many forests, also mining area. And it is between two existing cities, Balikpapan and Samarinda, which are major cities also on that large island. The reason for choosing the capital over here in this area is that it's sort of the geographic or the geodetic central point of the entire country. If you take the extremes on both sides, the north and south and the east and west of the country, then you end up on a cross point, which is more or less in this point. So the new capital will be in the center of Indonesia. It's an island state, as you would know, but this would be the center more or less of that country. Now, why is this an interesting example to do a study on land management and also using geospatial sciences? Because I think you create a new city in an area which is currently tropical forest. So that in itself is already a major land conversion, tropical forest into a city area. And also the reasoning is to create a smart city, a smart green city even. So how would you create a city that is smart, and how would you also create a city that is green? By cutting actually the trees and then create a city. So that would be an interesting question. And what are the land management problems that you may encounter? I would say that if you create a new city, there's lots of complexities. There is obviously current land use, there are current land rights, and you have to deal with lots of dynamics which will start to emerge once you create a city. Dynamics of urban growth, dynamics of energy needs, water needs, drinking water, wastewater, runoff water. There will be a change of land rights, land values will change. So the question is, how can we use current knowledge of geospatial science and of land management to, first of all, guide the establishment of that city, but also to guide the possible growth and all the dynamics that will take place, and hence end up with some general land governance support for that new IKN. That is the abbreviation of the new capital city, sometimes also called Nusantara in Indonesia. So from the land management side, we have various frameworks. We can describe the land management by this sort of conceptual equation. Land management is a function of lots of changes that, or any land management intervention is going to bring about lots of changes in terms of governance, in terms of legal issues, social spatial issues, economic issues, perceptions and behavior. And we can also use a normative investigation. Is this change of the capital, is that actually a responsible land management intervention? Is that change that we are going to create with that new capital, is that responsible? So not only sustainable, but also is it responsible? So when you look at the sort of descriptive analytical form, what is actually changing, we notice that the establishment of a new capital will create lots of changes in governance. The simplest change that we can see is that currently that area is being governed by the local regions or the local provinces, which are headed by Balikpapan city and by Samarinda city. And they already have their land use plans in that area. So introducing a new capital city with its new authority will definitely break or change the existing land use plans of that city, and you create a new land use plan. The question is then, to which extent is that land use plan, usually planned for 10 years, 15 years, to which extent is that still valid, and which governance is then still valid. Another major change is the change of forest land to residential land or industrial land. Now, forest is usually under the Ministry of Forestry, so in Indonesia at least, whereas residential land is under the Ministry of Land. So there will also be a competition between the two ministries. And there's also local people that actually live there. So there is a state intervention versus indigenous or local people that claim that land. So governance is an issue, legal relations. Currently, forest land is being managed by forest timber licenses, whereas now we're going to create land ownership or land use rights. So there will be changes of land rights issues. In addition, there's a change of perhaps indigenous land rights, which still exist in Kalimantan, versus now new statutory land rights, state land. Also social spatial relations. The whole design of the new capital is definitely a concentric design, right? Starting with the government area and then gradually building up a sort of concentric manner, the growth of the city. But we know from experience that very often cities, they grow along transportation lines. So if there is a transportation line from the new capital city to Samarinda and to Balikpapan, the two closest existing cities, then it's very likely that a normal development is going to take place along those roads and not along the concentric design. So that is something that we have to see if that will happen. And also it's a question of how much space for people is going to be created, residential space, how much green space is going to be preserved, and how much space for industry is going to be reserved. Is there at all any industry? If there's no industry, where will the people work that go to that city? So is also the estimation of how that city will grow, is that a valid estimation? Then there's the economic growth. Very often if you create a new city, it will attract also investors in that city. So is that capital city actually not creating a lot of accumulated capital, economic capital, rather than being the capital city? And are the prices of the land in that area not overrated or underrated once you establish the location of that capital city without actually building something? So we see already that values are increasing of that land without any construction. Now, is that leading to problems of affordability later on or not, both for the government to buy up that land, but also for local citizens? And two issues which are always a little bit more difficult to assess is the perception. Do people really perceive the new city as a new capital city? Everybody knows currently that Jakarta is the capital city, and people feel in Jakarta they are living in a capital city. But that new capital city, is there enough identity with that city? And lastly, also the behavior. What are the behavior will emerge once you create a new capital city? Will people go there? What kind of socioeconomic development will take place? So that's one side. The other side is the normative question. Was this at all a responsible decision? And can we learn from previous examples, for example, of moving the capital city? Now, here we use the 8R framework, and the 8R framework looks at 8 Rs listed here. And for every R, we look at very specific questions. Is it actually responding to a need? Is it creating resilience? Is it robust enough, etc.? So these 8 Rs we can apply for this decision to move the capital city. And we also look at, for every R, is the structure responsible, the processes of execution, and are the outcomes or the impacts responsible? And that should ultimately result in completing this matrix. Are the 8 Rs responsible in terms of structures, processes, and impacts? Now, here we can learn from other capital cities. We have looked in previous studies to these cities, Brasilia, Brazil, Abuja, Nigeria, Dodoma, but also Berlin and Bonn. In Germany, we also had 2 times removal of the or relocation of the capital city. So we can use from those examples. And we see that in these examples, they also used very similar justifications of moving the capital city. A more central location. If you create a new capital city, then you could create a population representing all peoples of the country. It's a new alternative to existing cities. It's moving away from coastal areas, which may be vulnerable. Jakarta itself is quite a vulnerable city, lots of flood, very populated, etc. And we could, by designing a new city, also avoid the mistakes of earlier plans. And very important, you create a new national narrative. So previously, Jakarta was obviously the legacy of the colony, coincidentally the Dutch colony. So by creating a new city, you could create a new national narrative, which is totally Indonesian and no longer related to colonial legacies. Now, if you then apply sort of the 8 Rs, then actually you can raise a couple of questions. To which extent has this move to a new capital city, has it been consulted with citizens or even with responsible agencies? I know that, for example, when I talk to citizens of Jakarta and I ask, are you willing to move to the new capital? Then nobody says, okay, I'm willing to move to Kalimantan. Most people would say it's actually very far away. I don't have family there. I don't see any need. And also, is this new capital actually the need of Jakarta itself, or is it the need of Kalimantan, the area where you're located? So there you could raise a couple of questions. But also in terms of all the other 8 Rs, there are some serious questions that you could raise. For example, To which extent have the structures been reliable for the assessment and monitoring? For example, do we really achieve the green capital city or the smart capital city? To which extent do people also are involved in co-deciding on decisions? So I guess for all those 8 R's, there are some serious questions we could raise. So that in itself, I'm not critiquing the Indonesian government, but at least I use that as a way of discussing and also predicting these are some of the things that could go wrong in that new capital city, given these questions. And on the other hand, the responsibility, on the other hand, we can also use a couple of geospatial tools in order to predict or to create a number of scenarios to figure out what could happen with that new capital city. First of all, how will that capital city grow? What are expectations based on previous examples? What are the needs in terms of energy? Can we also make use of renewable energy? If it has to be a green city, then one would expect the city to rely on renewable energy rather than sort of coal and mines. How will it work out with water? Where will the water come from? Things like that. What sort of problems will we get with land use, with land rights? And finally, also, how do we deal with land values? How do we control that in that new capital city? So we use that questions in order to do a number of geospatial studies. Most of those geospatial studies start with estimates of urban growth. How will the population grow? Now there we use some examples of previous capital cities. Once we have the urban growth predictions, then we can also predict how can the infrastructure grow or to which areas will that grow, energy, water, transportation. Then we can also make some land use and land rights predictions. And finally, we can come up with recommendations for spatial and land governance. And perhaps also assess what will be the role of that new capital city in the regional development. So that is what we have done. So we started a little bit with assessing the urban growth, and that was done based on scenarios that we found out in previous capital cities. So there's a study that we did in 2020, actually, and 2021. We noticed that there's actually different scenarios of urban growth. Some capital cities grew much faster than was anticipated. Some grew much slower than was anticipated, and some had sort of a steady growth. So we cannot say there is this scenario, but there are 3 scenarios. Much faster growth, urban explosion, basically, a much slower growth, it remains a sleepy town, and a sort of steady growth. And these 3 scenarios we took into account. For example, a city like Dodoma in Tanzania, actually it's a sleepy town. Still, if you go there, there's almost nobody that went there. Also, the president only goes there if he makes a decision, then he flies back on the same day, etc. If you look at Abuja in Nigeria, it's an explosion. Now it's already a city of like 8 million people. It grew much faster than actually anticipated. And therefore, there's lots of problems with water, with energy, etc. So we use these examples to formulate 3 sorts of scenarios. We also used the sort of average growth of those previous cities as an indicator for the 3 scenarios. The ghost town, sleepy town, the urban explosion, and a sort of decent growth. So these are the growth rates of that we used in our scenarios. And then it's a question of in which direction is the city growing. Now, there we can make use of all sorts of urban growth models. Here I've listed a couple, but we chose in this research to use the CLUE modeling framework, the CLUE-S. in combination with an open source software, GRASS, actually a very old one. We tried to use ILWIS first, given my previous background, but it seemed to be easier to use GRASS. But you could do this also with any other piece of software. Then obviously we needed the maps, the land use and the land cover maps, as sort of a general indicator of how is land changing, what sort of land do we have in that, where are protected areas, where is forest, etc. And that went all into that urban growth model. And from that, we created several scenarios. So as said, we use the urban growth models from those previous cities, a very slow, very fast, and a very decent growth model. So here you see the equations that we made use of. Now that led to a first set of scenarios. So from that, you can calculate how the city might grow spatially. So here you see a number of scenarios without too much explanation, but I hope you can understand that there can be very fast growth and a very slow growth, decent growth, and the growth also depends on lots of terrain characteristics. You cannot grow very fast in hills, whereas you can grow very fast in flatland. And you can grow very fast in forest land, but then you have to encroach the forest land. So there you can indicate, will the growth actually enter the forest land or will it not enter the forest land? And can we control that growth in one direction? So various scenarios were possible. So here we saw some of those results according to the different growth scenarios and also according to certain land use policies. Without any land use policies, and that would be the current trend, then the environmentalists dream. So how do we protect tropical forest, for example? How do we not encroach environmentally sensitive areas with lots of biodiversity, for example? And really a green plan. So even how do we really forbid entering certain areas? So 3 scenarios, decent growth, fast growth, and slow growth, and 3 land use policies. Do nothing, protect the environment, or really create or maintain as much green as possible. That is what we compared. Now, from these figures, you may not see a lot of difference, but there are significant differences if you calculate it. So we did that for both decent growth and also for the urban explosion. And here you see really the urban explosion, in which directions it would grow. Now you clearly see it sort of crosses many other areas and encroaches many forest areas. Now, based on these urban growth models, we then went to figure out, okay, what sort of energy will be needed. So if it's not growing very fast, you don't need a lot of energy. If it's growing very fast, you need a lot of energy. Now, the current estimates, sort of the decent growth, they are based on a city of 1.5 million inhabitants. The fast growth even goes up to 5 million inhabitants in a number of years. And if we look simply at that number, we see that these amount of inhabitants need much more energy than is currently provided in this location. So the current electrical system is providing about 400 megawatts with 18 substation units. And if we look at the new environment, so the anticipated city, we actually need 6,000 gigawatts, which is much more than is currently provided. That implies that you need to create additional electricity facilities, which is not just additional volume of electricity, but also new electricity supplier stations. Then the question comes in, where does that additional energy come from? That can either be from non-renewable sources, but we said if it's going to be a green city, you should go for renewable energy sources. And then the question is obviously, well, from where? Is that wind energy or solar energy? And for that additional amount of energy, we can calculate again what is most feasible. So based on these predictions, we could say, okay, we need this amount of new energies, and we can calculate what is the potential for solar and what is the potential for wind energy based on the topography and based on the amount of wind and based on the amount of sun that is available in that area. So definitely much more energy needed. Can we generate that based on the sun, the topography, and the available wind that is in that area at all? So from that, we could calculate a number of scenarios and predictions again. We found out that actually that whole area has too low wind speeds, so it will be very difficult to create wind energy. But being in a tropical area, solar energy is abundant. So the first assessment would already be, let's go for solar energy. Then the question is, where do you locate those solar panels? So there's lots of scenarios that you can generate there, but you can either, the problem with solar panels is that you need a lot of land for that. So you would actually occupy a lot of land for all those solar panels. So there is two solutions for that. Either you create solar panels on existing or former mining sites, which are currently unused or underused, or you put solar panels not on land, but on water. So that would either be the ocean water or the river water that is also abundant in that area, or lakes for that matter. And both of these possibilities were also explored. Where can we then actually locate those solar panels? Now, again, this was based on quite an extensive geospatial analysis. We made use of Sentinel images, of Landsat images, but we obviously needed to do the classification. We made use of elevation maps, slope maps, because solar energy, you get more solar energy. The slope is faced towards the sun. If it's in the shadow of a mountain or a hilly area, then you don't get a lot of solar energy. So we could calculate some solar potential maps. So that is what we did in that study, to do a same thing with speed wind potential maps. And there we quickly came to the conclusion there's actually not enough wind potential. So we went for the solar maps. And again, I know that these maps are not very insightful, but if you look at the amount of solar potential, that there is a variance of solar radiation based on the topography and based on the amount of sun in that area. So you could actually establish locations, potential locations in the entire area where you should put up or where you have most of the advantage of the solar potential. The third scenario that we looked at is water, in particular drinking water. So that is a study that was concluded just recently. Again, we could use the scenarios from the first study. How fast is the city growing? And also we could use the scenarios of and the implications of water from the previous studies of previous capitals. So in Putrajaya, Malaysia, that actually is still a ghost town to a large extent, wrongly estimated population growth. So there is abundance of water as opposed to Abuja, explosion growth, there is actually a shortage of water. So these things we could also take into account in our predictions. So again, we could then estimate what is the water demand, and especially the drinking water demand. Now, then there's two possibilities for where do you get the drinking water from? Either from existing sources of drinking water, that is the river, groundwater, or rainwater. And a fourth possibility is actually importing the water by bottles, the bottled water, or simply importing the water by big containers. So that would be another. Definitely, we know from experience that there's a lot of water loss in providing the drinking water. On average, the water loss in Indonesia for providing drinking water is about 30% or 32% actually. So in the current pipelines and the sort of supply of drinking water, we have to take into account the average water loss. Also, there's water thievery, so people who don't pay for water, leaking pipes, etc. So that is what we have to calculate in this water demand that we need. Then the second question is, where do we get that water from? What we noticed was that there is a couple of dams and there is a number of reservoirs, but essentially these are providing the drinking water for the other cities that are already existing, Samarinda and Balikpapan. So we established that there may actually be a problem with drinking water if the city would go too fast. So again, from that perspective, you can conclude you have to be very careful with the governing that area to make sure that the drinking water is sufficient. So as said, a couple of scenarios we will look at. And also based on some population scenarios that estimate the demand and the supply. An additional item which is not related to the provision itself is also the water quality. So you really have to make sure that the drinking water is also quality. Other sources, so you have to make sure that you have the facilities. And you have to look in case there is not enough drinking water for other types of provisions of drinking water, such as seawater, desalination, rainwater harvesting, bottled water, groundwater, etc., besides the reservoirs that are currently available. Good. So, and I'll come to a conclusion quickly. So what are the next steps? I think what would be interesting to do is to create a digital twin. Now we are really at the start of this sort of urban development. And it would be nice if with a digital twin, a geospatial model, you could see how the city is actually developing and is it developing according to the plans. And that could provide the basis for more real-time monitoring of is the city actually developing according to plan? Combine that with active and passive sensors, and combine it also with remote sensing images, artificial intelligence, machine learning. Then you could really see if things are happening according to plan. We could also think of more interactive tools, voluntary geographic information, and we could think of designing more integrated land and water models, which definitely we see from these investigations. It's really necessary. Where do you put up solar panels? Where do you get your water from? It's really necessary that land, water, and energy is combined in one big spatial research and spatial plan. Another thing that we still need to work on is how can we actually regulate if things go outside of the plan? So what do we need to do if things are happening spontaneously or management tools which are either based on these responsible land management tools or based on, you know, which kind of decisions work best in this particular context. Because at the end of the day, it is a balancing act between what is planned and what is happening spontaneously and unexpectedly. These are some of the things that we really have to think of as being desirable or undesirable, such as the concentration of capital, speculators coming into that area, involuntary eviction, indigenous populations living in that area, uncontrollable sprawl that might happen, encroachment of forest areas and nature reserves. These are all sorts of things that might happen, and you have to make sure that you have the right tools to combat that. So this is an ongoing research. We are working on a number of publications. As you see, we have a number of publications already, and we'll definitely continue with that. And we are currently developing a number of research projects to continue that work further with partners from Indonesia and Germany, with designs of spatial information systems, with doctoral research, postdoctoral research, master research, and further publications. And any suggestions that can come up from Sri Lanka, from your community, would also be very welcome. Thank you very much. That was it from my side. I'm looking forward to comments and suggestions and further feedback, obviously. Thank you very much.
Thank you very much, Professor Rees. I think it's a very complicated and very long time I think you're taking for this research, I guess. It seems like a very complicated process for me, especially when you're monitoring the behaviors of you know, these dynamics, especially the structures and behavior of people. Seems like very interesting also, I guess. So yeah, I think now the floor is open for the questions and feedbacks. So I would like to welcome the audience to you know, raise your questions and you know, yeah. Please, yeah.
Okay, shall I go ahead with one question?
Yeah, sure, Dr. Ram, please.
Okay, I'm Miranda from the Faculty of Geomatics. So it's really nice to and interesting to see your presentation, sir. And yeah, especially you have talked about Indonesia. So I just curious to know how this, you know, like countries like Indonesia, when they are doing the planning and land management stuff. Now, if you take the Indonesia, is quite highly prone to the natural hazard, like, you know, earthquake. Even recently they had another one, quite devastating, and the tsunami. So how this, you know, these natural hazard things going to affect to this, you know, city development or urban planning and all this kind of stuff? So do you have any explanation or kind of a further, you know, comment on that?
Yes, it's a very good question and a very good point. Indonesia is prone to all sorts of hazards and daily have floods. Jakarta is being flooded regularly. It is sort of sinking. They have tsunamis, they have volcanoes. But remarkably enough, this area of Kalimantan was also chosen because there you have the least amounts of hazards. There are no volcanoes on that island. It is rarely affected by tsunamis or by hurricanes or typhoons in that area. So that is also one of the reasons to go there. Yeah. If you compare it with Java Island or Sumatra or the other islands of Indonesia, Kalimantan is more or less the safest.
Yes, you said it's quite highly dynamic and quite difficult to, you know, predict these stuffs. And yes, anyway, it will be definitely going to affect to this, you know, urbanization as well, right? Anyway.
Yeah, urbanization.
Yes, thank you, sir.
That is the issue that is concerning me the most, because that is quite dynamic, and the urbanization happens much faster in all parts of Indonesia than is currently planned. There's so many private forces, usually big development companies. That's why I'm sort of saying this accumulation of capital. big companies may come in and develop large areas without sort of consulting local government or maybe with some facilitation money as it goes. And so that's why it can go quicker than expected.
Yeah, thank you, sir. Okay, I'm done.
Thank you very much, Dr. Raghu. So is there any other questions? Dr. Jagat,
Hello.
yeah, Professor Jagat, please.
Someone
I'm
else.
from,
Yeah, sure. Please go ahead. Please go ahead.
I'm from India. I'm Dr. Ganesh Khadanga. It is indicated there are 8 hours for land management. How can you quantify these 8 hours and report in a quantified manner?
Yes, yeah, originally these were sort of qualitative indicators because we were asking more or less social political question. Is this a responsible decision or not? But you could potentially quantify it if you connect it to a set of indicators. But this is a process that I'm still working on. How do we translate things like robustness or reflexivity? How do we translate into quantifiable indicators? But if you have any suggestions, I'm quite open for that. But I haven't come to that quantitative step yet.
Okay, thank you, sir. Thank you.
Okay, thank you, Ganesh, Mr. Ganesh, Professor Ganesh. So, Professor Jagat, I think you have raised
Yes.
your hand. Yeah.
Thank you very much for the opportunity, and also thank you very much for the interesting case study. Of course, we have been experiencing this kind of capital city building projects throughout history. Not very recently, from the historic times. Of course, this has been happening, and in the recent era, maybe in the last couple of centuries, we know that a lot of governments kind of building new capitals, just as you mentioned. For several reasons, they give kind of explicit reasons saying, okay, maybe the resources, the land, and the management of population. But we know very well there are some implicit reasons, like for example, political kind of reasons that we cannot explain very well. In your now that we know very well that what happened in Chandigarh and very recently in India, that is Amravati, that is not built yet and which was given up. And also these some of the other projects in Asia, especially more or less to the same extent in the European and the American context as well. Now, when you work out these scenarios, like different scenarios, to what extent do you take into account this political kind of will and the change of political will, which is very likely to happen, change within no time? Of course, we have the similar experience in Sri Lanka as well. I don't know, for some reason, we have not captured that into your presentation. We also have a new capital city built 30 to 40 years back. Fortunately, it is a part of it's kind of not very far from the existing capital city in Colombo. It's now it has become more or less a kind of extension of Colombo, right? So that in that way, we didn't have that much of a complications as you have shown in your some of the cases that you studied. My question is, okay, to what extent have you taken into account this kind of the changes in the political structure, political kind of the arena into your predictions?
Right. Yes, and in all those case studies, we have seen, at least observed, the political justification, and very often they are very similar. A better identity, anti-colonial nationalists. So in a way, the justifications are similar, but I didn't want to touch on the politics in our study for that reason, because I cannot change the politics in other countries. So I wanted to deliberately focus on what, let's say we just accept that the decision has been taken, but what are then the consequences? Funny enough, we didn't pick up on the Sri Lankan case, so maybe we have to do that again. You have to send me the information, but from what I hear, it sounds very much like the Malaysian case, where Putrajaya is actually very close to Kuala Lumpur, so it seems more like a suburb of the capital city than really a relocation of the capital city. But I guess we took especially into account a capital city that is far away from the current ones, Islamabad as compared to And Pakistan, for example, is far away. Brasilia, Abuja, things like that. So because there you really create something entirely new. And it's a question of will it develop according to your plans or not.
Right. Okay, thank you.
Yeah.
Okay, thank you very much, Professor Garbu. So I think, yeah, we are getting the end of this session. But before I just want to ending this part of this session, I would like to know how do you think of utilizing the agent-based model, to is it feasible for applying in this kind of scenarios, or is it?
Yeah, I think that would be an interesting way of looking at how things are developing. Definitely. So yeah, let's include it in one of our master doctoral topics. It's sort of an ongoing research, I would say. But I guess at the moment there is nobody living in that new capital. But so you would like to see the behavior of individual people, of course, and then accumulate that over time and over space. But that can only be done as soon as people are actually there. That I think that is the problem currently. But I'll include it in my list of possible topics. Definitely, yeah. You may supervise that as well if you like.
Let's see. Thank you very much, Professor Breeze. I think you take a lot of effort and a lot of time for these sessions, and I'm very much thankful for you for your participation in here. So now it's time to move to the presentation sessions. So for that, I would like to invite our session chair, Professor Jagat Munasinghe. So first of all, let me give you a brief introduction of Professor Jagat. So he's a professor in Department of Town and Country Planning and former director of urban National Physical Planning. And he's obtained his PhD in National University of Singapore in 2014 and obtained his master's in 1993 at the University of Malta. So he obtained also his bachelor's degree in University of Malta. He has a lot of publications associated with the urban planning and town and country planning. So I think he's a prominent character in this field, and I would like to invite him for take the chair of this session and also continue with the floor. But also in that, before I handing over to him, I would like to introduce the judge panel also to today's event. So I would like to welcome Dr. H. Utura, Head Department of Surveying and Geodesy, as well as Dr. A.K.R. Ranasinghe, Senior Lecturer, Department of Surveying and Geodesy, and also Ms. Samanthi Munasinghe, Senior Lecturer, Department of Surveying and Geodesy. So the floor is yours. So please continue with the next sessions. Thank you very much.
Okay, thank you very much, Dr. Milinda. Okay, thank you very much for the introduction, nice introduction also, but I don't know whether I'm prominent or not, but whatever it is, I mean, we have to give the prominence to the kind of presenters today. But these prominent presenters, of course, I have to set some ground rules for our presentations because we have 7 presentations. It's a kind of lengthy session it's going to be, but whatever it is, the time allocated is limited. Therefore, every presenter has to limit their presentations to maximum of, let's say, can we agree upon 12 minutes so that we have 3 minutes at least to kind of questions and answer sessions. So what I would suggest is we'll have the questions and answers coming at the end of the presentations. So we'll go one after the other into the presentations in a kind of sequence. And thereafter, we'll have some time, common time for all the questions coming from the panel, right? So the audience. So let me invite the first presenters. The paper is on geoinformatics-based land use cover changes and its ecological impact on Andaman and Nicobar Islands, with special reference to coral reef. Paper is presented by written authors are the K.M. Ramachandran and Sumit Sadidran. Are they here today with us? Do we have Ms. Ramachandran and Sadidran here with us today?
Yes, sir.
Yeah, okay. So let's start your presentation and make sure that you complete in 12 minutes. Thank you.
Very well, welcome to the Faculty of Geomatics of the Second International Symposium on Geoinformatics. The theme of the International Symposium on Geoinformatics being the Geoinformatics for Conquering New Frontier Towards National Development. The topic on which I am going to present today is geoinformatics-based land use land cover changes and its ecological impact on Andaman and Nicobar Islands with special reference to coral reefs. I, Ramchandra KM of Dr. R. Satish Center for Remote Sensing and GIS, School of Environmental Sciences, Mahatma Gandhi University, Kottayam. The terms land use and land cover are often used interchangeably, but each term has its own unique meaning. Land cover refers to the surface cover on the ground, like vegetation, urban infrastructure, water, bare soil, etc. Identification of land cover establishes the baseline information for activities like thematic mapping and change detection analysis. Land use refers to the purpose the land serves, for example, recreation, wildlife habitat, or agriculture. There are certain factors which affect the land use and land cover of an area, such as population pressure, tourism sector, natural calamities, expansion of agriculture, and introduction of new types of cropping. The population pressure, which certainly calls for the construction of buildings, which would eventually give rise to the deforestation, and the same goes with the tourism sector, which calls for the construction of resorts, recreation centers, etc., which, when constructed in forest areas, would certainly bring a little damage to the forest. The natural calamities, which are quite inevitable, would also bring a lot of damage to the environment around us. The aim is to study the land use, land cover changes, and assess its ecological impact on the island, with a special reference to the coral reef. The objectives of my study are the assessment of land use land cover changes in the Andaman and Nicobar Islands over the years 1990, 2000, 2010, and 2020. The spatio-temporal change analysis of coral of Andaman and Nicobar Islands and the impact of developmental strategies on an island's ecosystem and biodiversity. The study area which I chosen were the Andaman and Nicobar Islands, which is the Union Territory of India, and it consists of 572 islands, of which 38 are inhabited at the junction of the Bay of Bengal and the Andaman Sea. The three islands, Andaman Islands, Little Island, Andaman, and the Great Nicobar, were considered as a study area. The Andaman Islands, which comprise more than 300 islands, of which 208 were considered for the study. North, Middle, and South Andaman, known collectively as Great Andaman, are the main islands. Others include Landfall Island, Interview Island, the Sentinel Islands, Riches Archipelago, and Rutland Island. The Little Andaman Island is the fourth largest of the Andaman Islands of India with an area of 707 square kilometers, which lies at the southern end of the archipelago. It belongs to the South Andaman Administrative District, part of the Indian Union Territory of Andaman and Nicobar Islands. It lies 88 kilometers south of Port Blair, the capital of Andaman and Nicobar Islands. The Great Nicobar is the southernmost and largest of the Nicobar Islands of India, situated at the north of Sumatra, and situated south of all the other islands and home to Indira Point, India's southernmost point. The study specifically focuses on interpreting the changes in land use through classified satellite imagery and supervised classification method, and with the help of intersecting tool, the results were obtained. The data source primarily being the land from the Landsat series. The satellite images of the 4 years were taken, and the supervised classification was done, and through that, land use and land cover map was obtained. and by performing overlay analysis in GIS using the intersecting tool, the change result was obtained, and through change analysis, the identification of change and statistical generation was made possible. The same goes with the coral mapping. From the supervised classification, the image was processed, and from that, coastline emergent vegetation was clearly visible, and from that, the habitat was mapped. And with the Great Nicobar Island concept plan, the plan was vectorized, and by overlay analysis and intersecting tool, the results were obtained. And the results from this study shows that there was a decrease in the forest area, and there was a great increase in mixed crop with built-ups in urban areas and increase in agricultural land in rural areas. There was a decrease in coral population due to marine population, tourism activities, construction of coastal resorts, and collection of coral reefs by the tourists. Tourism will be the first and the worst affected in case of calamities like earthquakes, tsunamis, and cyclones, which occur here regularly in Great Nicobar Islands. The economy of the island mainly relies on the agriculture, tourism, and small-scale industries, which calls for the development in the region, resulting in loss of biodiversity. Hence, sustainable development is the need of an hour. Figure and the table here depicts the pattern of change of Andaman Island from 1990 to 2020. And here there is a pattern of area change of Little Andaman Island over the year 1990 to 2020. From the table, it's visible that a lot of area was changed to built up areas, mix a crop with built up, etc. And of which barren land, forest area, and water body were changed. And here is the pattern of area change of Great Nicobar Island from the year 1990 to 2020. Here it's the pattern of coral reef change over the years 1990 and 2020. From the table, it's quite clearly visible that there was a great declination in the coral population, but in the Great Nicobar Islands, it's the other way. The coral, the marine population, under certain environmental stresses, the symbiotic relationship between algae and their host corals break down. With the increase in the sea surface temperature, the coral bleaching, tourism activities, construction of coastal resorts, natural calamities, the 2004 tsunami were the major factors for the declination in the coral population. Based upon scientific input related to seismicity, tectonic setup, and earthquake occurrence, earthquake-prone region of the country has been classified by the Bureau of Indian Standards into 4 seismic zones, namely Zone 2, 3, 4, and 5. Zone 5 is highly vulnerable to earthquake, whereas Zone 2 is the least vulnerable. Andaman and Nicobar Islands are located in Seismic Zone 5. The proposed developmental plan falls in an eco-sensitive area, which subsequently will affect the forest and indigenous people living in Great Nicobar Islands, and the island is home to two tribes, the Shompen and Nicobares. A large portion of the island is covered by dense forests, which are home to a variety of endemic biodiversity, including the Nicobar micapod, the Nicobar tree shrew, and the Nicobar long-tailed macaque. This this was a proposed concept plan for the Great Nicobar Island, and here would be this would be land use land cover change of the Great Nicobar Island if the concept plan was brought into action. And this graph shows the change in pattern of land use land cover if the Great Nicobar Island concept plan is brought into action. Study I came to the conclusion that the land use land cover pattern in the study area has undergone various changes over a period of 30 years. It shows the degradation of forest area and coral reefs. By providing better or new spatial analytical capabilities, this can improve impact prediction and assessment, as was noted by several consultants in the survey. There is, however, still room to improve and increase the way GIS analytical tools are being used for EIA. Better ways to link environmental methods with GIS, new and better GIS functionality for EIA, and increase awareness of EIA practitioners of the current GIS potential must be developed. Need and importance of sustainable development are to balance our economic, environmental, and social needs, allowing well-being for now and upcoming generations. Sustainable development encourages us to conserve and enhance our resource base by gradually changing the methods in which we develop and use technologies.
Okay, thank you very much. Thank you very much for the presentation. And I realized that it's a kind of recorded presentation, pre-recorded presentation, right? Okay, thank you. You are just in time. Okay, there may be a lot of interesting questions, but let's take them at the end. So let me invite to the second presenters, that is KASY Kasturarajji, Milinda Pesena, PAV Vitanage. That's on the Dissent constituents, Dissent constituents influencing the interoperability of spatial data in relation to the national spatial data infrastructure, NSDI of Sri Lanka. Right, it's a new project. Well, let's see how it goes. Let me invite the presenters, please.
Good day for you all. You all are welcome to my research presentation on discern constituent influencing the interoperability data in relevance to the national spatial data infrastructure of Sri Lanka. This research was supervised by Dr. Milinda Pesena, Senior Lecturer of Faculty of Geomatics, Sabaragama University of Sri Lanka. Knowledge on what existing, where is an important factor. So spatial data, also known as geospatial data, a physical object that can be represented by numerical values in geographic coordinate system. Knowing what existing, where is what, basically support all the economic development, environmental management, and social ability is in a SDI. SDI is what we call a spatial data infrastructure. Due to this dynamic and complex nature, it is still a very new concept to many. Due to this, SDI is all about the facilitation and coordination of exchange and sharing the spatial data between stakeholders of the spatial data community. There are many different definitions for the SDI, but what important is SDI enables data sharing between spatial data community for development and decision-making abilities. So Sri Lankan national SDI is still in development stage in respect to overcome many challenges. Therefore, it is important to investigate and complication challenges in interpret spatial data among different institutes. The problem is that a lot of information residing within various government ministries, departments, and agencies. As they are different government offices, they are following different objectives, and they have their own collection of spatial data. Consequently, data that is being created cannot be used in an open platform. So as my research problem, I try to investigate and analyze complications and challenges to interpret spatial data among different institutes. Because Sri Lanka National NSDI is still in development stage, so in order to take the full benefit of the NSDI, it's important to understand what are the challenges that we are facing. Collection of spatial data, consequently data that is being created cannot be used in an open platform. Objective of my research is evaluate the spatial data interoperability between government organization associated with land governance. To answer my main objective, I have derived sub-objectives which are review land governance agencies against geospatial standards and identify and evaluate the challenges for spatial data interoperability. Qualitative research methodology was applied in this research. In the literature review, I have identified problem and objective identification. In the data collection, I have interviewed decision makers in survey department, land use planning department, urban development authority, department of forest, department of meteorology, which were the institutes that I have taken for this study. So I have used to questionnaires to investigate decision makers and policymakers in this department to identify the framework for analysis. After deriving the framework of analysis, I have taken expert opinions survey using guided questionnaires to evaluate the field of assessments that I have derived from the guided questionnaire. Using existing data and expert opinions, I have done qualitative analysis to sort out the information that I have received to answer my research objectives and the discussion. I have discussed the research findings to derive the conclusion and recommendation. Next slide is a qualitative data framework that I have used to identify the answer my research questions. So identification of spatial data, data quality information, spatial reference information, entity and attribute information, metadata reference information, human resource and knowledge, policies, guidelines, and standards are the field of assessment used in this research evaluation. Department for investigating using the above mentioned framework, using existing data in each department, I have sorted out the information that I have received those departments into the framework. After doing so, I have taken the expert opinion survey by interviewing experts in the department that investigated to further evaluate the framework. First framework, identification of spatial data. Identification of spatial data is about identifying what type of spatial data available in relevant departments. So spatial data can be categorized into digital vector fundamental, digital vector thematic, digital raster hard copy, images and tips, and so on. After I investigated these things, I have taken the expert opinion survey on that particular field of assessment. As you can see in this graph, 9 out of 15 experts say that it has the highest impact on the data interpretability in Sri Lanka. And second one is data quality information, which can be identified as a completeness, data precision, data accuracy, and data consistency. When investigation department show that only the survey department has full set of complete data available. According to the expert opinion survey, we can see received respondents from the expert of the survey. We can see 12 out of 15 participants said that the data quality information has high value of impact on the interpretability in Sri Lanka. Then we go to the next one, spatial reference information. Spatial reference information is what each department wants to display for their work on the survey department, and other departments used their own. Survey department used to SLD99 Sri Lanka Grid as their fundamental reference information that has been derived by the survey department itself. For the data interpretability standards, 8 out of 15 participants said it's have a less important on data interpretability. Then we go to the entity and attribute information. Entity and attribute information on spatial data also important factor when considering the data interpretability, but only the survey department follow the ISO standards that are need to create in an entity and attribute information. And land use policy planning department also knows about that, but other departments does not have any idea about entity and attribute information that required for data interpretability. As you see in the graph, responses received from the questionnaire, 8 out of 15 participants said that highly impact on interpretability. Metadata reference information has been identifying the most important factor for the data interpretability standards in Sri Lanka. Lack of metadata information create difficult to users who want to use the data. Detailed data content cannot be identified without metadata. The create of metadata must be given priority should be done along with the data preparation activities. Only the survey department and UDA follows the ISO standards that required to generate a metadata in a standardized manner. You can see 12 out of 15 experts say that it is greatest impact on the interoperability in Sri Lanka. Next one is human resource and knowledge. In order to carry out the highly technical tasks, they are also found that human resource and knowledge also play an important role in data interoperability. Only survey department people have academically qualified bachelor's degree or relevant field questionnaires in regarding spatial sciences. And all other departments have awareness about the technologies in spatial sciences. And that the last one is policies, guidelines, and guidelines that can be long things to explain, but you can see in the graph there are a lot of policies and hinders the data sharing abilities among the different institutions in Sri Lanka. And as with the questionnaires also we have found that the policies and guidelines also plays an important part in data interoperability in Sri Lanka. So with the research, I have concluded the metadata, concluded that the metadata availability in the highlighted issue, 80% of expert identified metadata availability has the highest impact on the data interoperability. 93% of experts identified that human resources and knowledge is a major constraint in spatial data interoperability, as human resources are needed to complete such a big task, and survey department has legal restriction on sharing spatial data also. In meeting the data needs of many organizations is always logged into the National Mapping Agency for their information requirement. Adoption of standards critical issue in the interoperability needed for national spatial data infrastructure to function. When compared with other departments, spatial data created by survey department is the most standardized. For the development of SDI in Sri Lanka, recommendations, the creation of metadata must be given priority and should be done along with the data preparation activities. Operational level staff's awareness should be improved regarding interoperability standards, and educating the staff is recommended. And the spatial data sources should conform to common standards that enable integrating with other data, where such integrating enables efficient and effective solutions for users. That conclude my research and research findings. Thank you for your valuable time.
Okay, thank you very much. That is also a recorded presentation, I believe. So thank you, Sadam. And then while having a lot of questions, of course, I'm sure that we can raise questions. There are a lot of things that we can get clarified by you, but leaving that for a while, let me invite to the third presentation, that is by YGDPK Tenekon, NH Lianage, PADV Vitanage, and R. De Silva, SL Vitana, and in the PSN we have 6 authors, okay, 5 main author and 5 co-authors. The title is Fit for Purpose Solutions for Problems Associated with the Land Use Planning and Land Consolidation, Bevathan GN Division as the case study. Let's go to the presentation.
Good afternoon, everyone. I am Pasante Ennakon, undergraduate student of Faculty of Geomatics. Here for a talk is designed to act as a springboard of case study in Bevathan Gramidari Division of Sri Lanka under the guidance of Department of Surveying and Geodesy, Faculty of Geomatics, and the Geotech Hub of Sabaragaon University of Sri Lanka. I will move the study area as the commencement of this case study. Bevathan is the study area located within the central province in Sri Lanka, with mentioned latitude, longitudes, and the elevation, with 566 population and 154 acres extent. The main income source of this village is tea plantation as well as pepper, cinnamon, and coffee. The nature is sloping area. Wevatanna is very hilly area. The water resources are water springs and natural streams, and literacy level is comparatively low because Megahakula is the nearest town for this Wevatanna village. It is also far away from the Wevatanna village, nearly 20 kilometers. And the special problem in this village is no proper land demarcations in land plots. I will walking towards the background of this project. We are studying and paying attention for the land use planning and land consolidation strategies. As a developing country in Sri Lanka, with growing population, it is the better to find proper solution for the emerging problems in land use planning and land consolidation activities. This study aimed to address major issues in rural villages and find interventions in accordance with the social environment in a modern manner. Wevatanna Gramilari division is located in between Ellalanda and the Pitamaruwa Gramilari divisions. This Google Earth image shows how the land plots are spread in the Wevatanna Gramilari division. In feasibility study in this project, we identified major and sub-objectives. The major objective is to identify the land management related problems and feasible solution in the rural area of Sri Lanka in a scientific manner. As a sub-objectives, using modern technology and tools, identifying the problems and related to land management infrastructure and other problems that faced villages, and find a solution for above identified problems and discuss the capabilities to implementing that solution on the ground level. Identify how the government officers, institutions, and non-government officers, organizations collaborate village. And finally, identify the opportunities related social and economic for the improving their lifestyle. There were different kind of methods were used to collect data. First one is on-field observation. In here, we use a special method called LTPR matrix under the six matrices: forest entry, freshwater, lakes, river, groundwater, land tenure, women and land resource matrix. Second one is questionnaires. Third one is key informants, and fourth one is PRA. PRA means participatory rural appraisal and GPS surveying. As a secondary data, we use maps, survey plans, especially final village plan, and finally data analysis. For this data collection, we intervene some resource person, divisional secretary of Megahakula, and the Gramilari of Wevatanna, and UDA officers and resource persons in division secretariat of Megahakula. When we implement the project, we followed this methodology for our project. First one is literature review for LTPR matrix and PRA, then collecting data for each method and analyze the result. Using this result, we identify critical land parcel, identify the major problems, evaluate the contribution of the government officers. Then using these three, we come to finally construct the interventions. In detailed methodology of the LTPR matrix, from one side, literature review for the LTPR matrix and prepare the questionnaire, assign weights, data collection for questionnaire, and analyze the data. On the other side, select the study area and create base map. You see, from these two sides, identify the critical land parcel, then construct the interventions. Data methodology of PRA, first same as literature review for the PRA, then criteria selection. There are three methods. First one is discussion, problem tree, and chapati diagram. Using these three methods, we analyze data and come to the identify the major problems. And other side, evaluate the government officers for contribution. This is the PRA which we held. And this is the chapati diagram we observed. After analyzing data, we identified critical land parcel according to the LDPR matrix. Through this study, we identified major and minor problems and the difficulties in this area. The major problem in this area is lack of land rights and the fragmentation. This means no proper programs to land settlement and registration, lack of permits for the government lands, presence of the boundary issues. When we walked around the village, there were several walking fence in between the forest conservation and the land plots. And another problem is drinking water and sanitation issues, informal use of available water sources, and the families without water supply facilities, and the problem of the water management. As the result of this water and sanitation issue, people tend to illegal alternatives. And another problem is land degradation and non-conservation. Unsustainable natural resources management, water, the land, and the forest resources. And another problem is inadequate infrastructure. Ititample is the nearest village for the Vevatanna village, but at least there are no proper road to the Ititample. And the majority of the families suffering from the poverty. As a result of this, failure to manage income and expenditure, and the income in fluctuation. And in difference to the quality of the existing agricultural products. And other than these problems, one of the major issue of this village in the youth labor migration out of the village, unskilled labor and informal employment. Most of the people are suffering from the poverty, as I mentioned. So younger generation tends to leave the village to the cities for the better lifestyle. As a result of this severe problem, 70% of the population are adults in this village. For solve and mitigate the damage for the village, special proposals and the suggestions were constructed. Major one is the land settlements and the land registration, demarcation of the forest reserves and the land parcel, providing the land to landless families, and the implementation of drinking water supply and the sanitation products, implementation of a special project on the water management and environment conservation, making special intervention for the unsustainable natural resource management, as well as making special interventions in land degradation and increase in the productivity of land, and the increased awareness in the community about the revenue expenditure management, preventing out migration of the youth labor and increase in training opportunities, as well as providing sales opportunities throughout IT facilities, and the develop a program of a religious leadership of the guidance. That are the proposal we identified. And on the other hand, government can bring certain field officer services closer to the village, like community policing service, land use planning officers, colonial officers, coordinator of the Buddhist affairs, rural development officer, social development officer. As a conclusion of this project, large and negative effect on the society externally can be generated through the land conflicts, and the land consolidation and land use planning are the main aspects of the land management that shows imports in the environment issues locally as well as globally. The result explain the capabilities to implement solutions for the burning issues on the ground level, and the land use planning and land consolidation strategies towards the village economy and the villagers' well-being accordingly.
Right.
A special thanks go to Dean Faculty of Geomatics, Dr. Milinda Pearsena, Divisional Secretary of MEGAKIT. Thank you very much.
Okay, thank you very much, Basan. Let's straight away move into the next presentation. That is by WDRV Walisingh, JSR De Silva, PhD V Vithanage, SL Vitharna, NM again Milinda Pearsena. Right, the title is Impact of Land Tenure Security and Real Estate Investment in Bandarabal Municipal Council Area for the Development of the Tourism Industry. Let's listen to the presentation.
Sorry to disturb, but I think this presentation has not been given, so we need to move to the other one.
So, do we have the presenter here with us?
No, I think not here.
Not there. Right. Okay. In that case, let's move to the next presentation. Right. Again, by SL Vitharna, NMP Milinda Pearsena, PhD Vitharna, AIUD Silva, and MATS Munasingh, Samanthi Munasingh. That's a review of the performance evaluation of low-cost receivers under different environments for cadastral surveys.
Welcome to you all. In this presentation, I'm hoping to enlighten your thoughts on low-cost GNSS industry, which is currently getting popular among the community as well as surveying professionals. My motive in here is to emphasize the positives on using low-cost GNSS technology in cadastral survey. My name is Sanchita Lakshan, and let's move on to the presentation. As we all know that cadastral surveying is highly concerning about the position on the ground due to its legal aspect. With that, surveyors are always trying to adopt methods where they can assure that the location on the ground is given by the exact XY values measured by the instrument. For that, use of GNSS technology is highly considered option which are readily available in the current market. But acquiring such technology costs a surveyor several thousands of dollars, which they are hesitant to invest at the moment. This has automatically enhanced the importance of acquiring GNSS technology at a low cost. After several years of research and development, number of companies now has started to manufacture low-cost GNSS receivers, which has the capabilities to observe chord as well as carrier phase measurements. Yet, still, it was only a few hundreds of dollars. Some companies are manufacturing GNSS receivers for navigational purposes, where the user is unable to access to the raw range measurements. These receivers calls are SIRS chipsets. And some of them allows the user to access the range of measurements so they can improve the accuracy and precision using different accuracy enhancement methods. This technology has opened many doors to the Intelligent Transport System services, we call them ITSS, as well as Location-Based Services, LBS applications. A major advancement of the low-cost GNSS technology is that the architecture of these types were diverse and similar to geodetic receivers. And also, the number of channels are getting higher and higher, so the receiver can observe number of range measurements which automatically improve its positional accuracy. When it comes to improve the positional accuracy of low-cost receivers, several support systems has adopted. One of the popular methods was using RTK methods. Researchers have identified that by using either patched antennas, survey-grade antennas, or either using smartphone receivers, the ambiguity can be resolved and the performance will be improved. Also, using NRTK method such as coarse networks, the low-cost receivers are able to acquire real-time corrections, so the reliability, productivity, and accuracy can be improved. One major way forward of the low-cost GNSS industry was that since it has allowed to access the raw data, the atmospheric modeling such as ionosphere and troposphere can be done, so the end user can improve the positional accuracy furthermore. One major drawback of the low-cost receivers are its susceptibility to the noise. Many researchers have identified that by adjusting SNR value constraint that can be used to filter the required signals more efficient and effective manner. Also, there are two methods to identify the receiver noise, named by zero baseline as well as ultra-short baseline test, where it gives the vital information of improving overall performance of the low-cost GNSS receivers. With that, number of researchers have found out that using low-cost GNSS techniques can perform well in the expected level according to the legal provisions to acquire positions pertaining to a particular country. So this is the end of my presentation. I hope you gain some knowledge about low-cost receiver GNSS technologies. So thank you very much and have a nice day.
Okay, thank you, Sachinta. So, okay, low-cost GNSS. Okay, that's an interesting presentation. Okay, so that we have two more presentations to go. Let me invite again PSDV Vitana and SL Vitana, JR De Silva. That's the one we have already done, right? Is it? I'm a little confused here that, no, sorry, that's one. It's okay, fine. And the present of the paper that is generating the highest resolution orthophotos and digital elevation model for construction of salinity barrier across Nilwala River, Madhya district. Do you have the presenters here for the presentation?
Good evening to the chair and the rapporteur of today's panel, and my fellow researchers. Today, we are here to demonstrate you about the feasibility of extracting the ground surface under the canopy cover more accurately using UAV imagery and LiDAR processing. The topic of the analysis is generating the high-resolution orthophotos and digital elevation model for construction of salinity barrier across the Nilwala River. So let's move on to the presentation. In this presentation, following topics will be discussed in detailed manner. The main objective of the construction of the salinity barrier across the Nilwala River was to filter the fresh water which contains with lot of silt due to unregulated sand mining throughout the banks of the river. Also, rise in the sea level has become another issue when supplying fresh water, drinkable water, to the common general public who stays around the main city. For that, solution of constructing the salinity barrier at a high cost has become a pivotal approach for the above problem. With that, using unmanned aerial vehicles, we call them UAVs, was used to identify its potential of extracting the ground surface even under the canopy cover. Overall, these applications of UAV technology has become a high popular and accurate survey method was the main reason to implement it on this project. So by using UAV, following objectives were focused to achieve under the above mentioned research project. Those objectives are provide the basis of identifying +1 meter contour and demarcate the 0.6 meter contour and measure the exact inundation area during the gate close period of the Mathura stage for water supply project. As you can see in the slide, the chosen study area was around 60 hectares along the Nillora River. To establish the control network, 6 primary control points were established using GNSS technology and 10 checkpoints and 10 GCP points and more than 200 spot heights were taken as cross-references. The environment was a bit gloomy, which was ideal for feature capturing using UAVs. Locations of the GCP were distributed effectively throughout the study area, and more than 80% of front and side overlaps were maintained for the better accuracy in the point clouds and 3D models. Also, following outputs were generated through softwares to build the final output. These are the instruments used as the equipment for the survey as well as for the feature extraction. Under methodology, we have proposed the reconnaissance survey as the initial stage. Later on, we proposed the GNSS survey, UAV survey for establishing control network and feature capturing. After that, we generated and validated the outputs, the 3D models, point clouds prior to the generating contours, DTM and DSMs. At the final stage, the required outputs were proposed to be at the high accuracy. These are the generated outputs from the proposed methodology. You can see that the proper orthomosaic, DTM, and DSM were accurately generated after using the obtained data. After the results generation stage, a separate process for ground truthing has been carried out. You can see that the built models were able to maintain an accuracy of 1 centimeter horizontally and 5 centimeter vertically. This research project has shown you that by using UAVs, capturing the digital area images for stimulated coordinates and archaeological models for large-scale mapping is an achievable task. So this is the end of my presentation, and thank you very much for your listening.
Okay, thank you very much. Okay, let's move to the last presentation on digital India land records management information system using open source GIS product. Okay, if I'm not mistaken, that must be Bunaksha, right? Okay, presented by Ganesh Khadanga, DS Venkatesh, MV Sunesh Kumar, Shanmuga Soundaraya, and so on. I mean, there's a series of the authors, but anyway, let's listen to the presenter and later on we can get them introduced. Thanks. Yes, please go ahead.
Hello, respected conference chairman. My topic is Digital India Land Records Management Information System using open source GIS product Bhunaksha. I am Dr. Ganesh Khadanga, Scientist Staff, National Informatics Center, New Delhi. My email is ganesh@nic.in. My outline of the presentation is as follows: motivation, background information and related works, Bhunaksha features, sample screens, Ulpin, future work, Matruhumi. Motivation. India has about 6.4 lakh villages. Cadastral maps were prepared in 1:4,000 to 1:8,000 scale during late 19th to early 20th century. Digital India Land Records Modernization Program emphasized to modernize the management of land records. The basic need of this program is updation of these old cadastral maps using modern surveying techniques like electronic total station, global positioning system, aerial photography, high resolution satellite imagery, and coarse network. The cadastral system in India consists of Revenue Department, which deals with computerization of land records, basically attribute data. The Settlement Department deals with survey and resurvey of village maps. The Registration Department deals with registration of documents. A brief history of the various initiatives taken by GEOWEEK, and year-wise it is also indicated. We started in 1984 with pilot studies and taken up only 13 districts. Subsequently, we went with 1987 the SRA ULR program. Then the CLR program started in 1988, and after that we took a project known as scanning of cadastral maps. Then the Bhumi project was taken up. In 2008, the NLRMP program, National Land Records Modernization Program, has started. In 2010, the Property Registration Computerization has started. In 2016, Digital India Land Records Modernization Program has emerged. In 2017, we started with the National Generic Registration Document System, NGDRS, and in 2020 we taken up Samhita project, survey of villages and mapping with improvised technology in village areas. The Digital India Land Records Program, the objective is to modernize the comprehensive and transparent land record management system. It is a step towards the conclusive land titling or torrent system. The torrent title system operates on the principle title by registration rather than registration of the title. The basic principle of the torrent system are the mirror principle, where the register reflects or mirrors accurately and completely the current facts about each title and the registered lot, and the ground map is also reflected and matches with the ground. Curtain principle, one does not need to go behind the certificates of the titles as it contains all the information about the title. Indemnity principle provides compensation or loss caused by the private fraud or error made by register of titles. The Bhunaksha product is developed as a tool, and it is developed in-house by NIC with open source Java library known as GeoTools to facilitate and managing the digital cadastral parcels. Bhunaksha is suitable for the states where cadastral maps are in use. With proper customization, Bhunaksha can be integrated with existing land records application of any state. The basic features of the Bhunaksha are developed using free open source software, works in Windows and Linux platform, centralized architecture, operable in browser and desktop clients, plugin architecture to facilitate integration with ROR of the state database. A plot can be divided into multiple subdivisions in a single mutation, multiple methods for creating division lines, history and audit trail of the division is also maintained in the software, distance measurement and calculations taken into consideration with the initial scale and local units. Maps can be displayed and printed in any scale. The SLT based style sheet is used for pictures or alamats. Layer on the plot can be displayed and printed. Query based thematic maps can also be printed. Bulk import of the save files into the database is possible. Maps can be generated from electronic total station and FMD data. Validation of reports comprising of data and ROR and digitized maps helps to correct the geometry errors in the save file. User management and role-based authentication is there. The Bhunaksha current version is 3.0, consists of the modules as shown. The save file import, view plots, layers, themes, plot editing, merging and reports. Customizations can be done for ROR linking, customized imports, customized reports, customized operations. Basically, we use GeoTools, Postgres, PostGIS, and Open Layers. Once the shape files are imported into the Bhunaksha, after selection of the locations like district, Tehsil, RI, Halka, and the seat number, we can display the village maps like this as shown on the right side. This is for another state. The map is also shown along with different codes and color codes for the different areas. Individual details are also shown. You can see the bottom detail, the land type details are also shown. Individual plots can also be viewed along with the RORs, where adjacent boundary information is also shown. The printable reports of the plot area to any scale can also be done. The village map printing in A4, A1 sheet along with the alamas of the pictures can also be done. The updation of the plots because of cell mutation inheritance can also be done by splitting of the plots and by using the dividing lines or as desired by the user. For example, here you can see from a specific corner you can go a particular distance and angle, and you can make the division of the plots, and you can give the new plot numbers. Similarly, you can do arcs on the adjacent sides. You can go a specific distance and draw a circle like this. From here you can draw, and you can join the points like this, and you can divide a new plot as indicated by the user. The arcs can also be drawn from the adjacent lines. Individual plot points can also be generated from the distance taken by the vertices, and a plot can also be generated like this as desired by the user. Sometimes merging of the plots is also essential. You can select the plots and you can merge them. The field measurement book or the Tiphon data is basically the sketch map. Along the baseline, the right hand side and left hand side attributes were written in Excel sheet, and this can be imported into the Bhunaksha, and plots can be displayed like this. It can also be shown over the web, and individual FMB can be generated individually, and it can be plot given to an individual user as ROR. Georeferencing of village maps is also possible. When a map is not georeferenced, it can be georeferenced with respect to the background satellite imagery, and it can be done. Plot comparison reports, like when import a shape file, the number of plots in the shape file and the number of plots in the ROR should match. Any mismatch, it also be reports. Any duplicate information or anything missing is also reported. Mutation report basically indicates how many mutations has occurred in a day. What are the new plots has been generated by the division is also generated. Bulk import of the villages can also be done. A number of shape files can be imported simultaneously. It is possible to request a map plot any specified scale by providing parameters, and input-output can be embedded in a ROR. A plot information from one vertices to another vertex and distances can also be done. Import of the village reports is also indicated. It indicates the village name, plot number, and sheet number, and total plots. Sometimes unimported list is also there, and it is also printed. Validation of the shape files can also be done with the help of Bhunaksha. The activity log indicates the activity time, user ID, remarks, and what are the new plots has been done and generated. It is very helpful in security of the application. The ULPIN, basically unique land parcel identification number. It identifies the plot uniquely by the 14-digit number, and we assign this plot to each and every plots in the cadastral map. It can be displayed like this. It can be displayed with the background satellite imagery also. The Swamitwa project, survey of villages and mapping with improvised technology in village areas. Basically, it is a UAV survey of property cards. This property card basically displays the plot boundaries and also shows the ULPIN number. This is a very essential document for a citizen to get loans. Coming to the new features, we are coming with Mathrubhumi, where we will like to display all the cadastral parcels over the India map like this, and if you click a plot number, you can also get the details of that plot. We are also further going to link Bhunaksha with NGDRS, and this is our next initiative. Thank you.
Okay, thank you very much, Ganesh. Right. So with that, we conclude the presentations. So we have the luxury of having about half an hour for questions and answers. Right. So let me open the floor for questions and answers. But I believe that I have the privilege of raising the first question, right, to any of these presenters. So let me ask kind of simple question from a few presenters, of course. The first one, that is with the national spatial data infrastructure, that is coordinating between the different organizations. That was kind of a interesting kind of a study that was presented by Kasturu Arachi, right? Okay, do we have the presenters here? Is there anyone from that set of authors, either the main author or the co-authors? Not there?
I think they should be here.
You're one of them.
They're here, I guess.
Yeah.
Okay, so right. Okay, fine. So it's interesting that national data infrastructure. I mean, the last presentation that we have with regard to this, in India case, that is the Digital India Land Record Management. I believe that's how we are trying to develop something similar to that, not the same, but something similar to that. But this project has been kind of flying for the last 10 years or so, as I know, right? So what do you think is the kind of main barrier? I mean, for the project to kind of proceed through, what type of the limitation do you find in the your presentation showed that, of course, all the agencies see that it's as an important kind of a project. Yes.
presentation में हूँ मैं अभी मैं वहाँ presentation join करो
Hello. So do we have anyone to answer?
Sir, should I say anything, sir?
Yeah, I'll come back to you, Ganesh, but I'm talking to the presenters from the NSDA, that is Sri Lankan one. I'll come back to you.
Okay, sir.
Do we have anyone to answer the kind of the set of authors in the paper on the NSDI?
Saddam is online. I think his mic is muted. I told him to.
Hello.
Oh yeah, he's
You're there, right? Yes, Saddam. Yeah.
Yes, I didn't hear the question, sir. But
actually, your presentation is fine. It's timely, and of course, we know this project has been running for the last 10 years or so, and not much progressive for some reason, right? And what do you think is the main kind of obstacle for it to kind of race through? I mean, even though all the organizations see that it's an important project and they know the validity and everybody's kind of are willing to kind of construct it, but for some reason it's not, it doesn't proceed kind of very fast. So what do you think is the reason? Could you sense anything with your research?
Yes, sir. What I have sensed is during the research, many of the organizations that involved in this project didn't have any human resource. That the people who are involved in this matter, they need the very highly technical training. So the people who are working with department didn't have such a proper training to do the task that needed. When I mean in the data collection process also. So has been in only this department had the human resources that are capable of doing such things, but when we are considering other departments, they don't have such human resources. That was the main issue that I had sensed in the data collection process.
Okay, mainly it's a matter of kind of not having kind of people with competencies, right? You have their capacities.
Yes.
Okay, right. Thank you. And with that, okay, let me talk to Ganesh from India. That is all in this India Digital India platform. So to what extent could you kind of enlighten us on to what extent this data that particular platform is used by the different agencies for their different planning and implementation activities? How successful is it?
Okay, good afternoon, sir.
Yeah.
As you know, we have 36 states. In all the states, the Bhunaksha is operational. And some of the states which have successfully implemented are like Madhya Pradesh, Karnataka, and Tamil Nadu, and all the states they have implemented. And most of the states have also extended it to the field measurement book also. Some of the states where it is fully matured, they have gone with some agencies, but most of the time the implementation is done by the states only.
Okay, right. Okay, thank you for your response. And let me shift to our other friend from India. That's about the Andaman Islands that you study on this interrelation.
Yes, Andaman Island is also using.
Yeah. Right. Okay. So then, in that particular study, it's about this land use change and the coral reefs. So you studied. I mean, your presentation showed that there were kind of changes in both land uses and the coral reefs, right? Because of the coral reefs, but it was not very clear how kind of causative one from the other kind of. Is there a kind of relationship between these two? Of course, we can hypothesize, but is there anything that you studied about it? Is there any relationship between the kind of ground changes and the kind of coral reef impacts? Are they interrelated? Could you establish something like that? Hello, Satindran, are you there? Ramachandra, sorry. Yeah, please go ahead.
Interrelate the depletion coral reefs with that land use and cover, right, sir?
Yeah, I'm asking. You have shown that there are two. I mean, both the coral reefs and the land uses have changed over a period of time, over a period of 30 years or so. We would like to know. I mean, either are they kind of related to each other? Okay, we can hypothetically say so, but do we have enough evidence to show that they are causative or kind of interrelated? Is there anything that we can scientifically prove that? Well, we all understand. We all usually say climate change is impacted by land use change, but there's no kind of scientific reasons as established so far. So I'm interested to know whether you have got any kind of relationship like that could be established with your data, with your research.
I primarily use that satellite images of the various years. And I compared them and collected from the area, and also the land cover change. I've been there to Andaman for like 2 to 3 months, and I had conversation with the people there, and they also said that a major development has happened in that area. I mean, in the state itself, and also the depletion coral change. It was also quite visible from the satellite imagery itself. Yes, sir.
Right. Again, the question here is, of course, I'm not quite sure whether we still can establish strongly that one is related to the other. Of course, there can be a lot of other kind of external factors, as you very, very correctly mentioned in your presentation. Also, the tsunami and the other thing that is coming from, which has no control with just no relationship with the land use changes. This is the kind of difficulty that we have, I believe, in Sri Lanka. There are a lot of changes happening in the coastal resources, but there's no way that we can establish that they are impacted by what is happening on the ground, land use changes. I mean, it's not strongly established. We hypothesize, of course, but no strong reasons as to show that they are related to each other. Right? Okay. Anyway, right. Okay. Let's kind of leave it there. And okay, one last question. Okay, let me take the Bevatana case that is in Ubu province. Now, Prasanna, now we have mentioned that this village is basically isolated by people. I mean, most of the youth are kind of going out of the village. So, in the national context, do you think that now these kind of lands should they be kind of evacuated in a kind of long-term scenario in development? and rather kind of attracting people to urban area, kind of more kind of areas where with more infrastructure and more facilities, and leaving these lands for either kind of larger scale plantations and the forest or whatever, because of the difficulty in developing this land. Even though we can kind of subdivide and kind of get the land ownership and all these problems can be sorted out, but you still think that it's worth kind of doing that kind of investment on them? Are you there, Prasanna? Prasanna, right? Am I right?
Is Pasan. Pasan is there?
Pasan. Sorry, Pasan. Yes.
Yes, sir, we here. So can you repeat the questions again, sir?
I'm asking that your study in this very remote village in this Vavatana, right? So it's a very kind of a remote area, far away from even this, as you said, this Himalaya, right?
Yes, sir.
Yes, okay. So when we think of long-term development, okay, true enough, the land ownership and the kind of matters related to the land has to be sorted out. But still, do you think that the effort is worth in terms of the development trends that is happening in the country? Yeah, most of the young people, as you very correctly said, are attracted to the urban areas, looking for kind of better and quality of life and all that. And should we kind of invest so much on that land matters sorted out, or rather leave them for either the forest or kind of bigger plantations that can be kind of productive in that way, rather than kind of parceling and giving it to smaller kind of families and all? What is your opinion on that?
Yeah, yes, in most recent era, young people are always trying to go to urban areas, but in here we identified that the main problem for youth is there's no opportunity for work spaces. There are lack of spaces. That's why they go to the towns for their occupation. But if we could establish a training institutes like vocational training institutes, it will beneficial for them to stay in the village. And when considering
Prasanna, my question is very question is, should we do that? Should we keep them in the villages rather than kind of
when considering about the development of the village, it should be due to this village, because there's no lack of job opportunities, so many problems. Then it should be introduced such kind of works to this Vavatana village.
Okay, this is a kind of I know it's going to be kind of a debatable question, because I mean, rather than asking them to be in the village, kind of develop the village, is it profitable in terms of national, beneficial in terms of national development, for them to be attracted to other areas where the infrastructure is already available, and optimize their utility and provide them better living opportunities in those places, leaving these lands for kind of maybe the forestry and the other kind of developments.
If I jump into the question, I think the problem is now if we try to promote the urbanization, and sometimes, because sometimes we don't have the as we have seen these presentations, what we observed is that the urbanization continues to try to explore. Then we expect, and if we not plan well, trouble like COVID-19 conditions, right? Have happened that time. The village is more sustained than the city. Because most of the time the villages like the feeding. They are feeding actually the urban areas. So most of these we try to motivate these isolated villages come and settle in urban areas. Probably, I think it's my personal opinion actually. Probably, would rather unbalance the both systems, I guess. That is what my personal opinion.
Yeah, that's what I said. I mean, we can have a debate on it. Of course, we have to understand this. Sri Lanka, the population growth is very, very minimal. Of course, we have a kind of declining rate of population growth. Of course, in future, we cannot expect the kind of explosions like in Indonesia and the Kenya and those places. Mostly, the kind of population explodes. Of course, we understand. So the urban areas naturally grow faster because of the population growth. And in our country, of course, the rate that we are growing now, unless these young people like Vasan and Saddam and people do something about it in future, thinking they have kind of families, it's very unlikely that we will have a growing population in future. So that manner, it's very difficult to think that we will have that kind of explosion even in our urban areas. Let's kind of anyway. Let's I leave it to think about it. Right. So with that, of course, I'll give the opportunity to the others, and if time still available. After all, let's have a couple of questions to the other presenters as well. Okay, I'll leave it to the audience. Of course, it's your turn now.
Can I start?
Sure.
Actually, I'm very interested some kind of question from the first presenter. Okay. Actually, even Professor Jagan Singh raised this issue. You did a kind of land change analysis for the two islands. And also you mentioned in your presentation, can you hear me?
It's good.
Okay. You're looking for kind of coral reef identifications. Even you have shown some maps how they were degrading. Actually, when I saw your methodology, I saw you use the Landsat images. Could you please little bit explain? Actually, the similar thing asked from even Professor Jagat, but anyway, we didn't receive very clear answer.
Ramchandran, did you get the question? Do you have any?
No, sir. It is kind of unstable.
Nishamuni, I think your voice was breaking, but could you repeat the question again, please? Hello? Nishamuni, are you there? Right, we'll come back to you. Okay, until such time that she's connected, let's move into another question. Anyone else?
Professor Jagat, can I ask?
Sure, please go ahead.
It's not a great question that it's kind of deep of the national spatial data infrastructure in Sri Lanka. What about Kasturi Arachi mentioned that interoperability issues and data and interoperability? Just what is the reason major of this interoperability problem from the data collector's perspective?
Can you elaborate on that? I didn't understand the question that you are raising. But did you
Yeah, my question is that, I mean, what may be the major reason of these interoperability issues? I mean, from the collector's side, if you think about it.
Sir, what I have understand throughout this session is throughout the research every department has their own objective and collecting their own data. So they are collecting they are only used. They have never thought of sharing the data with other departments also. So they never had that kind of vision. So they are precision of data interoperability when collecting data. That is the main problem that I understand. They collected data only for their use.
Okay, Saddam, that you mentioned that the department is maintaining good standard data set. From my point of view, how I see the problem is that the problem is that we need to have a mechanism in order to share the data. But the problem is that there is no such mechanism from the provider side and data collector side. They are not willing. There are organizational issues create a lot of problems. Specifically, especially the survey department need to get a key role here. If they maintain a good set of data, and even if they can get a good pioneer role here, I think this your suggestion can be possible. Yes, it's my idea about.
Have made a very huge impact on data sharing also. The government can implement some policies that can collect all the data and
Thank you, Saddam. Thank you, Dhruv, for the question. Of course, I know that survey journalist department, they are very cooperative. Of course, they are very kind of ready to share and ready to some of the not every data, but most of the data they are ready to share, and they would like to have this kind of credibility. I believe so, right? Okay, but what is lacking, I believe, is the as Saddam correctly said, the other organizations are not prepared to change their formats, their standards, and the data that they collect. I think that orientation takes some time, right? So and also top of there must be someone to lead this process. However much the survey department and the organization are ready, there is no one to kind of propel it from leadership. So that is one of the main reasons why the process not kind of proceed.
I jump in this point. The ICTA needs to play a big role in here because they are the one who needs to provide the technical infrastructure. But still, when we discuss with them, actually they don't. They have started in 2011, I guess, but still they are developing the systems. And some of the systems seems like very complicated because they have so many layers. So it's very difficult to deal with all data because there has to be somebody has to be updated, but then the updating mechanism has been centralized. That's one of the main problem of this NSTI I observed. And if one organization the responsibility of a department to update these things, centralize things, and it's very difficult to update the data. That's what I observed.
Yes. Okay, with that, let's kind of focus on to the other presenters as well. Any questions from the audience to the other presenters? We have a yes,
can I ask one question to
okay, sure, go ahead.
How do you identify the coral reefs from Landsat images?
The Landsat image was classified first as a color, and the corals they can be identified by the pristine blue color, which are.
So which are the bands used?
Just 3, 4, and 5.
Can you specify that?
Specify what?
Specify the bands, color.
Primarily RGB.
Your mic is muted.
I'm not quite sure about that, but it was depicted using that, colors basically, and also from the ground data also. I mean, as corals, they can be found near the shore.
Right. Okay, so we have a few more presentations with regard to this Nilwala project. And we have presentation on the low-cost receiver technology and all that. Can we have a few questions to them as well? I'm sure that they are interesting presentations and a lot of things that we can discuss.
May I proceed, Jaga?
Sure, of course, jump.
I'm sorry about the last time we had sorry. Yeah. Actually, if I move to the Nilwala research, so I think Tanagi, right?
Nilwala project is presented by
actually, no much question, because really for this research they use very high technology, high resolution images from UAVs, and they develop all the photos, DSM and DEM in high resolution, in high accuracy. But my intention is, I think this may be some middle of the research. So you have to focus on how you can design, because the focus actually goes for the salinity battery. So actually I'm really looking for how you can design, or how you can arrange salinity barriers across the Nilwala River. Actually, as one living in Mathura district, so actually I would like to know your research. It's a good, it's a very important research, and it's a very required research to present day, especially for the area like Mathura. Okay, thank you very much, Tanagi. So I'm looking for the upcoming results from your research studies. Okay.
So Tanagi, are you there to respond? Hello.
Excuse me, sir.
Yeah,
I'm also a participant of that particular research. I can give you a comment on that. Actually, madam, we were not supposed to give the construction authorities to give the place for the construction authorities to build the sanitary barrier, because it's already being built at the moment. And the thing is that they don't have any idea about undated area after closing the gates of the salinity barrier. That's why we were involved with the national government, basically the National Water Supply and Drainage Board, in order to find the exact inundated area which is occurred due to the gate closed after the closing the gates of the salinity barrier. They just wanted to find out what is the exact inundated area after closing the gates of the salinity barrier, and they had some ideas based on some survey data which was previously obtained from the other surveys, but actually that was not the case. I mean, we are observing and researching that particular area, because actual inundated area is extremely very large area is going to be inundated after closing the salinity barrier. Obviously, we know that Nilwala River is a very shallow river, and of course, the people who are living in the beds of the Nilwala River are really will get suffered because of this salinity barrier. And we thought to make it a future run as well, to find out the exact inundated area, because that particular area is most likely to go further upwards to the particular Nilwala River. So we are looking forward to continue the research on that and find the exact inundated area caused by the salinity barrier gate closed. So thank you very much.
Okay. Yeah. Okay, thank you, Sanchita. So I actually the way the situation is not simple as we as you explained, right? So
Yes,
you
yes,
have to do a
sure,
lot
sure.
of studies. Yeah, yeah. Thank you, thank you.
Yes, people, those who got impacted by this project only know the kind of gravity of it, right? Okay, it shows very well how she feels about it. Anyway, right? Okay, let's move to the audience again. Okay, I mean, is there anyone?
Shall I jump in? Yeah.
Sure.
So I do have a question to the Ganesh. Ganesh, are you there? Are you here? Are you there?
Yes, sir.
Okay. So we are actually trying to have projects also for various project starts to try to implement the same kind of cadastral system, web-based cadastral system in Sri Lanka, and we are also now was able, because of the COVID-19, I think we have not been able to collaborate the things, but now anyway we have also developed the similar kind of website for the Sri Lankan context. But then what I want to highlight, what I want to know is that basically in your web-based GIS system, would it be possible to have a multiple logins, like you have a content management system so that multiple users can log in and update the data?
Sir, basically what we are doing, we are getting the data directly from the state servers and displaying it centrally in one server. All the updations and processes, everything is happening at the state level, and as a service we are getting the data from the states to the central server.
Okay, in that case, who is going to update the servers?
Suppose one state is there, any data gets updated in the central server of the respective state because of mutation, court orders, and other things. So we are getting only a service from the state to the central server. So in the central Matruhumi, which we have indicated at New Delhi level, that is the updated data is always available. All updations are locally happening in the states.
Okay, so in state levels also they have access to Gunashka.
Yes, the state level they have actually we got the data through their services.
So they are not submitting through Gunashka, but they are using different platforms.
Yes, they are different backbones. So different data centers are there at state level. We are getting the data from the state level data center to the central server through an API.
Okay, are they in digital format then? Yeah.
Yes, we have the web WMS services.
Okay, right. So thank you very much. Thank you. Yes.
Okay, we have space for one last question because only 2 minutes are available. So anyone who would like to pose the last question to any presenter? Anyone who would like to take the opportunity? Last chance. Right, in that case, if there's no one and no questions, I believe that this all the authors have mentioned their email addresses in the respective abstracts, which is available in the website, I believe. Am I right, Milind? Yes. Are these abstracts?
The chair is here. Dr. Indika, how do you
actually, yeah, we got the final version of the abstract, most of the presenters. So we are preparing the abstract book, and within a week we will publish and we will upload that into the website, so anybody can then download that.
Right. So all the presenters and their authors will be contactable through their email addresses, I believe, in the abstract book, so that if there are any more kind of questions and clarifications and objections, if you have, you can communicate into them. Right. Okay. Fine. With that, let me kind of thank everyone, including the presenters, the co-authors, and those who are here and also raise questions and have to contribute to the discussion. And thank you to Dr. Milinda as well. So with that note, I conclude the session. Let me hand it over to Dr. Milinda to kind of go ahead.
Okay. Thank you very much, Professor Jagat. I think you have done a wonderful job in conducting the sessions. So this is the end of now. We are at the verge of this session. So I would like to thank those who participate, especially the Professor Priest, the session speaker, as well as I would like to thank the Professor Jagat Munda Singh and for his valuable active task that he has performed here. And also I would like to thank Mr. Utlabi Ratna, Dean, Faculty of Geomatics for his visionary leadership. And also I would like to thank the chair of this organizing this symposium, Dr. Indira Prasanna, and also Secretary Ms. Surangi Bandara. As well as I would like to do my sincere thanks to all the members of the Dutch panel, Dr. K.R.N. Ranasinghe, Dr. Divitura, and also I think all the academic staff who have now participated in this event, as well as all the students and other persons participating here. And thank you very much. So then we are now concluding these sessions. Thank you very much for your presence.
Thank you very much, sir. So with that, we have now come to the verge of the second technical session of the day. And if I'm to kindly remind you on the upcoming technical sessions on 1st of December, which is tomorrow, the first technical session on hydrography will commence at 8:30 in the morning from the local time. And the next technical session on integrated spatial science applications will commence at 11:15 in the morning from the local time. And the final technical session addresses on remote sensing and GIS. And the session will commence at 2 in the afternoon from the local time. So all the presenters and participants can join to their respective technical sessions accordingly. So thank you very much for all your participation. And there's a small reminder to all the participants that the next event of the program today is the invited talks from SULECO Private Limited, which will be given by Stonex Italy. So this kind reminder is for all the participants to kindly remain in the session for the next event. Thank you very much.
Can start. Again, good afternoon, everyone. Welcome to this webinar on Stonex GIS solutions. This is Emma Antonacci, and today I will speak about GIS, and I will show you the Stonex product and field software for GIS survey. This is the summary of this presentation. We will start with a quick look on GIS technology and applications. So we will see what are the GIS survey tools and how to choose the right equipment for a GIS survey. Then we will see what does Stonex offer for a GIS survey, hardware product and field software. I remind you that at the end of the presentation, we will have time to answer all your questions. So please enjoy the presentation, take your time, and at the end of the presentation, write all your questions and doubts in the chat section on the right, and I will be happy to answer all of you. Well, what comes to your mind when we say GIS? GIS stands for Geographic Information System. It's a computer system for capturing, storing, checking, and displaying many different data related to geographical positions. So actually, it's an integration of two systems. The computer design system, actually known as CAD, and the database management system, since it connects many different information on a map and vice versa. So GIS answers at the same time both questions: where is and how is that thing there in that place? A lot of companies and organizations in each field today use GIS to create maps that communicate each other and share different information. Here we can see some few examples of field of matter where GIS finds application, like archaeology, agriculture, environment monitoring, facilities mapping and management, just like energy and gas, green census and tracking, forestry sector, but also healthcare, public security, real estate, very different and many applications. Here we can see just two examples of practical use of GIS. Every day, every time you use the satellite navigator on your smartphone to looking for the closest hotel, the best restaurant, you are using a GIS. And you know, the GIS is more relevant now than ever. Just think that the first application was during an epidemic in 1850, more or less, when a doctor made a study that located the number of infected people on a London map, a London cartography. And this was the result. So information is associated to a map. So to whom do we look to? For example, land use and urban planning professional must deal every day with a lot of data really different each other, but also architects, engineers, surveyors, industrial experts, and agronomists. So many applications for many and various customers and users. But what the user needs for a GIS survey? We can simply divide the tools for GIS survey in an hardware part and software part. Regarding the hardware part, the user needs something that something to take GPS coordinates to save the geographical position, so a GNSS receiver and a controller to manage the GNSS receiver, or just a controller and use the integrated GPS antenna to save the position, to take the coordinates. But we will see these details in the following slides. And in the same hardware device, the user needs something to take notes and picture, because it's not a classic topographic survey, it's a GIS survey, and we need to associate different information to geographical coordinates. Regarding the software part, the user needs first a field software to collect data and see all them in real time on the map or on a drawing that he used as reference, and an office software to prepare the job, to post-process the job, to elaborate the job, and the possibility to exchange data from office to field and from field to the office. And finally, the possibility to storage many information, so to manage a database in not a lot of time, and make available this information for other users and other applications. So now that we know what is GIS and what are the GIS survey tools, what the user needs, we will try to understand how to choose the right hardware for a GIS survey. Then, what hardware product does SULECO offer for a GIS survey? And then we will see also how to choose the right software and what software does SULECO offer for GIS survey. I think that the hardware for GIS survey should be the right balance between these three features. First, you need to respect the accuracy required for survey. Usually for a GIS survey is not required a high level of accuracy. So someone can think that an entry-level GNSS receiver is good, can be good, and sometimes it's like this, but you also need to consider the condition where you are going to survey. First, we have seen that you could work also in forestry, so in tough conditions. And you know, the performance of GNSS receiver, the precision of the instrument depends very much on environment conditions. So another important feature to be considered is the possibility to survey also in tough conditions. And the last one is the operating comfort. The user should be able to work in comfort. We have seen that I don't need only to move and take geographical position. I need to analyze the environment. I need to take all information possible from elements that I'm surveying, and I need to do it in comfort. So let's see the SULECO hardware product perfect for GIS survey. I will show you a GNSS receiver, just one a GNSS receiver perfect for GIS survey, a tablet that you can use as GNSS receiver because you can use the powerful integrated GPS antenna, and the controller that you need to manage the GNSS receiver, or that you can use alone if you don't need a high level of accuracy. Let's start with the SULECO S580 GNSS receiver. This is a very compact and little dual frequencies multi-constellation GNSS receiver. So GPS, GLONASS, BeiDou, and Galileo can be tracked and at the same time, and we will see later when we will see the SULECO software that you can choose if you want to use all constellations available or exclude some of constellation available. It's equipped with an Android system. It guarantees a high precision positioning. It has the web user interface, so you can connect to the instruments via Wi-Fi and access to the web user interface where you can check more details about the geographical position. You can check the configuration, change the configuration, change some parameters like NMEA messages, and check the firmware, update the firmware, and many other operations. The data transmission is possible via Wi-Fi, Bluetooth, and external radio. So you can connect a controller through Bluetooth and use the internet connection on the controller to receive differential correction from a network of permanent stations. So work in NRTK mode. Or you can also connect an external radio through Bluetooth to the instrument, so receive differential correction through the radio from another base. So work also in RTK mode. But you can also work in standalone mode with a single solution and at the same time record raw data. All RENET data are saved in the instrument, so you can download at the end of the job and post-process all raw data in the office to reach the RTK precision anyway. Another important feature is the hands-free design. It's very small. It's long less than 14 centimeter and large less than 8 centimeter. And the weight is 300 grams more or less. And you can use it on the pole or also in the bed case or in the arm support. These are standard accessory, so are included in the S508 bundle. So it's a very powerful GNSS receiver, but at the same time, the user freedom movement is guaranteed. StoneX S70G. This is an RTK handheld. So handheld with an internal GNSS chip, dual frequencies, and multi-constellation again. So GLONASS, GPS, Beidou, and Galileo can be tracked. And also in this case, of course, you can choose if you want to use all available constellation or not. This antenna that you can see here is the SA15 antenna, and it's a standard accessory. So it's included in the instrument bundle, and you can use it directly on the tablet for a more comfortable use, or on the pole to reach to obtain the right elevation. The accuracy is the same. The only difference is the elevation, that in this case is right, of course, is correct, of course. But we will see the different level of accuracy of all instruments at the end of the presentation. It's equipped with an Android system, so a very simple and intuitive interface. It has a high quality display. The dimension is 8 inches. You can work in RTK because you can connect an external radio via Bluetooth. You can work in NRTK because you can use the internet connection of the tablet to connect to a network of permanent stations. And also in this case, you can record your data. So you can work in standalone mode where you don't have the internet connection, and post-process all the raw data later in the office. All raw data, of course, are saved in the memory of the tablet. It's a rugged tablet with IP67 certification, so dustproof and waterproof. Now let's switch on the controller. This is the SH5A. It's an Android controller. It's equipped with an Android system. It has a tough design, so you can also work in extreme weather and temperature. It has a long battery life and a high quality camera. And as we have seen before, during a GIS survey, it's very important to take pictures and to associate pictures to geographical position. So it's a very important feature. The dimension of the display is 5 inches, and you can use this controller with the GNSS receiver to manage and configure the receiver, or alone with the integrated GPS antenna. It is a good antenna if you don't need a high level of accuracy. But again, we will see these details at the end of the presentation. And finally, the rugged tablet UT32, 8 inches, UT12P6, and S17, 8. All these tablets are equipped with an Android system, so a very appreciated interface. All these tablets are rugged and have IP67 certification, so waterproof and dustproof. Are drop resistant from fall from 1 meter, more or less, also space, and Verilog battery life. Well, now that we have seen the hardware part, let's switch on the software part. So how to choose the right software for a GIS survey? The perfect software for GIS survey should respect these three features. It should be user-friendly. The user need to work quickly and in an easy way, because it needs to collect a lot of data in not a lot of time. You need to configure the GNSS receiver or the internal GPS antenna on the controller to take the geographical position as correct as possible, as more correct as possible. And a GIS database has been supported. So you must have the possibility to collect a lot of data, different each other, and associate all these data on the positions, on the geographical position. And you need the possibility to exchange data, and to need these collected data available from you, from the office job, and from other users and from other applications. So also an office software for data manager, processing, and storage. As we have seen before, you can also record the data. So in that case, you need to post-process the RENEX data in the office. So you need an office software for post-processing. Now let's see the StoneX field software for GIS survey, GEOWEEK and GEOWEEK2022. GEOWEEK is the StoneX field software developed here in Italy for Android platforms, so with a very intuitive and simple interface. And with this software, you can manage a GNSS receiver, a total station, a GNSS receiver and total station together for a GNSS, a GPS and total station together survey. And you can also do a GIS survey thanks to the GIS options available in the GIS module of the software. So it's a complete field software, not only for GIS. Especially from the version 6, you have also the 3D module. So thanks to the Android interface, the operator's work is very quick and easy. You can connect and configure the external GNSS receiver or the internal GPS antenna on the tablet, and you can survey and stake out. There are a lot of CAD functions available. You can create 3D models in real time and calculate volumes. In this presentation, I will focus on GIS options available in this software, but for those who don't know yet, you can visit our website, StoneX website, where you can also ask for a demo version, a demo license. I will show you how to do it at the end of the presentation. In this video, we will see an example where I'm using the S70G with GEOWEEK software on board. I'm saving points, but at the same time, the software is creating a line between these points. So I'm drawing during the survey. I can move these element points line all in different layers. I can associate a code. I can see in real time all elements on the Google Maps as background. And as you can see, I can also show if I want the map rotate with me, rotate based on my movement. So this is a very useful function for staking working mode. Here you can see another example. I'm saving a point and I am associating a picture to this point. As you can see, the operation is very easy, quick. You can also draw on this picture, and thanks to the S70G that is very small and light, you can quickly and easily associate many different pictures and information to the points, and change also the symbol of the point. So now let's focus, as said before, on GIS module in Cubase software. This is the screen of Cubase where you chose the table of GIS attributes. There are already existing tables of GIS attributes. These I've highlighted in red. But you can also add new one. You can add new table of GIS attributes, or you can create new table starting from an existing one. So you can select an existing table of GIS attributes, clone, duplicate this table, and then customize these fields, the required fields. So delete some requests, delete some attributes, or add some attributes. You can also take a table of GIS attributes from a DBF file, as you can see here. This is not existing, this is not created, this is from a DBF file, from a shape file. Or you can also import a table of GIS attributes from an XML file. You have to copy this file in the memory of the internal memory of the tablet, and you will find this table here in the drop-down menu, where are all available table of GIS attributes. Well, once that you chose the table of attributes that you want to use for your survey, whenever you save a point or an entity, the related table appears, and you can associate the GIS attributes to this point, or to the line, or to the geometry that you are saving. You can also change the table of GIS attributes during the survey. An important feature in the GIS module on Cubase software is the utility locator support, available from version 6 of the Cubase software. As you can see in the device menu, there is the utility locator page that allows you to simple and quick connect the device via Bluetooth to the utility locator. We have tested the model RD8100, so all the previous models should be compatible, and if you have other models, please let us know and we will work for development. Once the Bluetooth connection is established between Cubase and utility locator, the table of GIS attributes already existing utility locator is automatically enabled. So when you save the points, automatically will appear this table, and all this information are automatically filled out, because all this information are from the detector. so can be set automatically in the software and associated to the point. You can also, as you can see, edit this table. So if you don't need some information like the, I don't know, the locate mode or the frequency, you can delete, or you can add other information that you don't find in this table. This table contains all the information that the utility locator all the information available from the utility locator. We already have implemented in the software. Here we can see an example. I'm searching for pipe. This is a pipe locator. When the locator prompts that there is something, I'm going to save this information. Then something appears on QBA. I have the time to move the receiver on the point to take exactly that geographical coordinates. And then, as you can see, all the information from the utility locator are automatically associated to the point that I'm saving with the GNSS receiver. These are all the information from the utility locator in this case. Of course, if you change the utility locator settings, so if you don't want the frequency, if you want other information, the settings that you do in the utility locator are automatically transmitted to QBA. But if you want to use another software for survey and at the same time use a SONEX GPS, the solution is the free software Cube Connector. It's a SONEX free software for Android to connect the Android device to SONEX GNSS receiver and to configure. You can also configure the internal GPS controller, of course, and then you can make available the correct coordinates from the receiver, from the GPS antenna, to third-party software, like QField or collector for ArcGIS from Esri. This is the interface of the Cube Connector. It's very similar to the QBA interface. It's more simple, of course. Again, with QBA, it's a complete software for connection and configuration of the instrument, but especially for survey and many other operations. Cube Connector is only for connection and configuration of SONEX GNSS receiver. Then you can use this software as mock location application and make available the coordinates from the GNSS receiver for other software that you use for survey. But as you can see, also in this software, you can enable or disable some constellation. You can choose between different working modes. If you want to receive differential correction from a network of permanent stations or from a base through radio, you can see more details about the position. You can always access to this software during the survey while you are using the other software to check the GPS signal status, detailed of the GPS signal status, and to change the configuration. As said before, Cube Connector, if you set Cube Connector as mock location application, it will replace the GPS readings from the internal device with the ones from the SONEX antenna. So the customer can use his software for GIS survey in Android operating system, of course, because also Cube Connector as QBA is an Android software. So, for example, you can create a very easy workflow from QField to the free software QGIS. And and back to the field, continue to collect data with the QField, and then make available all this data for QGIS. To conclude this presentation, a quick look on StoneX GIS solution. Actually, the complete configuration between hardware and software StoneX product. The first solution, perfect for GIS survey, is the S70G with the equipped antenna SA15. So you need only one instrument, the S70G, with QBay or Cube Connector on board. You can use, as said before, the SA15 antenna on the tablet or on the pole. With this configuration in best condition, the RTK working mode, you can reach in 20 millimeter horizontal accuracy and 30 millimeter vertical accuracy. Or you can use the S70G with the optional antenna. This is the SA65. It's connected by cable. In this case, you need the pole, and you can use QBay or Cube Connector on board. In this case, in best condition, in RTK working mode, you can reach an horizontal 10 millimeter horizontal accuracy and 20 millimeter horizontal accuracy, vertical accuracy, sorry. And finally, the S580 with an Android controller. So in this case, only in this case, you need two instruments, the GNSS receiver and the controller to manage the GNSS. You can use also in this case QBay or Cube Connector on board. With this configuration, in RTK working mode, in best condition, you have less than 2 centimeter horizontal accuracy and less than 3 centimeter vertical accuracy. I will remind you also that you can connect an external radio to the S70G or to the S580 GNSS receiver. Here is shown the StoneX Bluetooth external radio that you can also put on the pole, and then you can receive the differential correction by radio from another GNSS receiver that works as base, and this can be again the S580 because it can receive and transmit. Here, as stated before, we can see all instruments shown in this presentation divided by level of accuracy. So, of course, you have the GNSS receiver with 1 centimeter, the S70G with external antenna that is optional or standard accessory SA15 antenna, and the S580 less than 5 centimeter, the S500 and the S70 less than 1 meter, and finally the controller SH5A and the rugged tablet.